Okay, so the second set of questions on waves. First question, question 4, starts off by talking about a teacher measuring the speed of the waves in a ripple tank. What apparatus should she use? So you might remember seeing a ripple tank if you have it side on. There's your tank, it's full of water, and you make the waves go across it, and they can be propagated across, means they're moving across that way. So what apparatus should you use? An ammeter and a stopwatch, Newton meter and a ruler and protractor, ruler and a stopwatch. An ammeter, you might remember from the electricity, looks something like that. That's to measure the electrical current, so it's not going to be that one. Newton meter, well, Newton meter is all about force. I'm likely to use it in this example. Ruler and a protractor to measure angles. Wouldn't have said so. A ruler and a stopwatch, that's what we want. So we're going to measure the distance with a ruler and time it with a stopwatch. There's our little display. And we're going to go wave speed is distance over the time. So by knowing the time it takes the waves to cross the ripple tank and knowing the distance that it takes, we can calculate the speed. Well, question 5. An infrared wave travels at 2.0 times 10 to the 8 meters per second. So let's just have a little recap of that. That's 2 times 10 to the 8, that's 2. And then we're going to move the decimal point 8 times. 1, 2, 3, 4, 5, 6, 7, 8 meters per second. So let's go back, put the commas in. That's 200 million meters per second along an optical fiber. The wavelength is that. So we've got our wave speed and our wavelength lambda there. Calculate the frequency of the infrared wave. So hopefully you remember the equation V is F lambda. The wave speed is the frequency times the wavelength. We're asked to calculate the frequency. So rearranging that, we're going to have frequency is the wave speed divided by the wavelength. The wave speed is 2 times 10 to the 8. The wavelength is 9 times 10 to the minus 7. Okay, now if you're thinking ahead, we've got a huge number and we're dividing it by a really, really small number, so we're going to get an even bigger number out. Let's get our calculator involved here. So 2 times 10 to the 8 divided by 9 times 10 to the minus 7. And that's going to give me an answer of 2.222 times 10 to the 14. So, it's frequency, so that is hertz, Hz. We're asked to give it to 2 significant figures, so always make sure you read the question carefully. Let's round that to 2 significant figures. So we're going to have a look at that. It's going to be 2.2. Let's just make sure. Does that third one round it up? No, it doesn't. So 2.2 times 10 to the 14 hertz. And they've even given us a nice little space here, so let's put that down there, 10 to the 14. And they've given us the units, we don't need to add it in. Excellent. Right, question 6. A water wave for the frequency of that and a wavelength of this. Calculate the speed of the water wave. Exactly what we just did with slightly nicer numbers this time. So V is F lambda, the wave speed, or the velocity of the wave is the frequency times the wavelength. We're asked to calculate the speed, so we can leave it as it is. So V is F, frequency, 5.0 times the wavelength, 3.0. Oh, even I can do that in my head. That's going to be 15. 3 times 5, 15, and meters per second. And here we go, let's put that down there, 15. We're not told about any significant figures. So that's our answer.